Have you ever just kind of stared at a map or a grid and wondered, how does it all work? Well, it turns out there's this secret language hidden in all those lines, a secret that lets you measure distance perfectly, and get this, without ever needing a ruler. Okay, let's dive in and crack this code together. So, right off the bat, here's the big puzzle for today. Imagine you've got 2 points on a grid. You know their addresses, their coordinates, but you don't have a tape measure. How in the world do you find the exact distance between them? It sounds like it should be hard, right? But the answer, well, it's actually super simple. And the key is to stop thinking of this as a boring math grid and start seeing it for what it is, a language. It's a language for talking about space. Every single point has a name, its coordinates, and the relationship between those names, well, that tells you everything you need to know. And there it is. That's the secret right there. When 2 points are lined up perfectly, either up and down or side to side, you don't need to measure. You just let the coordinates tell you the story. And it all comes down to a little bit of subtraction. So let's break this down into a super easy 3-step method. First, you look at the 2 points and you find the numbers that don't match. Step 2, you subtract them. And step 3, you find the absolute value. Now, all that means is we're just after the pure distance, so the number is always positive. And that's it. That's your answer. Simple as that. Okay, so theory is one thing, but let's actually see the secret language in action. We're going to put this idea to the test with a few examples, and you'll see just how easy it is to get fluent in the language of the grid. All right, first up, a vertical line. Our points are 3,5 and 3,9. Now look closely. Do you see it? The x values, the 3's, are exactly the same. That's our big clue. It's telling us, hey, ignore me and focus on the numbers that are different, the 5 and the 9. So we just follow our method. We subtract the y values. The absolute value of 9 minus 5 is 4. And boom, just like that, there's our distance, 4 units. No ruler, no guessing. Now, the cool thing is, this works no matter where you are on the grid, even with negative numbers. So let's take these points, -4, 2, and -4, -5. Again, the x values are the same, so we can ignore them. We're just looking at the y values, 2 and -5. So what's the absolute value of 2 minus -5? Well, remember from math class, subtracting a negative is the same as adding a positive. So it's really just 2 plus 5. The distance is 7 units. See? The system just works. It's totally reliable. And you've probably already figured this out, but the exact same logic works for horizontal lines. This time, with points 7,2 and 12,2, it's the y values that are the same. So we zero in on the only things that are different, the x values, 7 and 12. And you know the drill, we subtract. The absolute value of 12 minus 7 is 5, so the distance is 5 units. It works the exact same way, whether you're going up and down or left and right. All right, you've learned the secret language. You've seen the code in action. Now it's your turn. Let's do a quick little lightning round to really lock this skill in. Okay, here are 5 challenges taken right from the source material. For each one, figure out which coordinates to focus on, do the subtraction, and find that distance. Go ahead and hit pause right here, solve them for yourself, and then we'll check the answers. So, how'd you do? Let's check them out. The answers are 11, 6, 7, another 7, and 15. That first one's a good example, right? 8 minus a -3 becomes 8 plus 3, which is 11. If you got all of these right, then congratulations, you are officially fluent in the grid's secret language. Seriously, nice work. So, okay, this is a neat math trick, but you might be wondering, why does this actually matter? Well, let's zoom out from the grid on the screen and see how this secret language is used all around us in the real world. Yeah, this is not just some exercise for a math class. It's a core skill for anyone who actually builds things. I mean, think about a contractor planning a wall. They're just finding the distance between 2 points on a grid, or a landscape architect laying out a perfectly straight path, or figuring out exactly how much fencing you need for a yard. It's all the same logic. It's the invisible grid that our whole world is built on. You know, this whole idea of a grid, of something that gives you a clear path from point A to point B, it actually connects to a much deeper, much older idea, our need for guidance. And this is where the source material takes a really fascinating turn, drawing a line between this mathematical clarity and, well, a more spiritual kind of navigation. The source brings in this verse from the book of Psalms. It's this really powerful metaphor about having a light to guide you on a journey. And here's the beautiful connection the source makes. Just like the coordinate grid gives us a reliable system to figure out where we are and measure our path, the author sees this verse as describing a kind of spiritual system that does the same thing for our life's journey, a framework that lights the way forward. And that really leaves us with a final, bigger thought. We've seen how this simple system of lines can bring order to what seems like just empty space. It really makes you wonder, doesn't it? What other invisible grids, what other languages or systems, whether they're social or personal, are out there, quietly guiding the paths that we all walk every single day?